Hi, welcome to Darling Fees channel. My name is X-Coco. In this lesson, we want to determine whether a solution is basic, acidic, or neutral. But before we do that, we have to go through some basic steps. So now let's start. We'll look at what we call hydration. Now, when we talk about hydration, it is the interaction between the gaseous ion and water, such that the ion becomes coordinated by a sheaf of water molecules. Now, how will we understand this? Let's look at this reaction here. So we have Mn plus X moles of water. Now, when this M combines with the water, we are forming M into bracket A2O. This means that the M here is surrounded by the moles of water. X here denotes the number of moles. Since we don't know that, that is why we are using X. Now let's look at a typical example. So we have Zn2 plus 4 moles of water, giving us Zn into bracket H2 bracket close 4 raised to the power 2 plus. So that means that we have the ion, which is the zinc here, which is coordinated or surrounded by water molecules, and that is what we call hydration. Now let's look at what we call hydrolysis. This is the reaction of water molecules with an ion or a salt to give acidic or basic solution. Take note, in this hydrolysis we are dealing with ions, not neutral atoms. So when we react that, we are supposed to get H3O plus or basic solution, which is OH minus. Now we have two types of hydrolysis, that is cation hydrolysis and anion hydrolysis. You will understand this as we progress. So all cation hydrolysis proceeds through 3 steps, except that of ammonium chloride, which proceeds by 2 steps. So these are the steps that we are talking about. First one here, the molecule involved will undergo what we call dissociation. Then the second one, it undergoes hydration. Then we have the final stage, which is hydrolysis. Now let's look at some few points. You should know that group 1 and group 2 metal cations do not undergo hydrolysis. Please, this is very, very important. So we have lithium, sodium, potassium, rubidium, cesium, magnesium, calcium, strontium, barium. They do not undergo hydrolysis. We will be using these ions as we progress. So please, take time and keep this. Then we also have anions that do not undergo hydrolysis. So we have fluorine, iodine, chlorine, bromine, NO3 minus, SO4 2 minus. These ions do not undergo hydrolysis. So it simply tells you that when you have, let's say, a metal from here and an anion from here, and they combine, then the solution will become what? Neutral. So as we progress, you understand this. So the first point here is saying that salts of strong bases and strong acids, when they combine, the solution is neutral. So when, let's say, you have ACl and you have NaOH, at the end you have a neutral solution. Now let's look at the second one. Salts of strong bases and weak acids, that will give us a basic solution. The third one here states that salts of weak bases and strong acids, the solution is acidic. So whenever you have a weak base reacting with a strong acid, the solution becomes acidic. The fourth point here is also saying that salts of weak bases and weak acids, in our case here, the solution can be acidic, basic, or neutral, depending on the reaction given. So as we progress, we will get to know why it is so. So this is a free gift. Most cases you have been asked to determine strong acids, strong bases. So these are some strong acids that we have. In fact, we have 7 of them that you have to memorize. So HCl, HBr, HI, H2SO4, HClO4, HClO3, HNO3. Then we also have some strong bases here. You can also keep this. So that is a free gift to all of you. Now let's move. There's a point here which is very, very important. It says that salts of weak bases and weak acids contain cations that will give acidic solutions and anions that will give basic solutions. So take note of that. Now there's a question here we have to ask. Will solutions of such salt be neutral, basic, or acidic? So based on the point here, are we going to have a neutral solution, a basic, or acidic? There is a key point here that we have to use in answering this question. It says that it depends on the relative strength of the weak molecular acid and weak molecular base from which each salt is derived. So it depends on the pair. So if you have a weak acid, if you have a weak base, how do you combine them to get the results? And that will determine whether it is neutral, basic, or acidic. So thus, salts of this class may be divided into 3 types that depend on the relative strength of the apparent weak bases and weak acids. So now let's look at the first one here. We have type of salt. So cation from strong base, that is anion from strong acid. We have examples here, KCl, KNO3. Now if you look at K, we can get KOH, so that is from a strong base. HCl, that is from a strong acid. So when they combine, you should be having a neutral solution. That is, the pH of the solution should be neutral. Okay, so we have KNO3 up to Ba to bracket NO3 subscript 2. They will all give you neutral. So we'll look at the mechanism behind this. Let's look at some few examples. So we want to know how we can break it down to determine whether it is acidic, basic, or neutral. Now let's look at the first one here. We have what we call sodium nitrate. Now the question is, sodium here, is it part of the ions that undergoes hydrolysis? NO3, is it part of the anions that undergoes hydrolysis? So these are some few questions that we have to ask ourselves. So we have Na plus here plus NO3 when they dissociate. This is what we are having. So the question is, will Na plus undergo hydrolysis? Will NO3 minus undergo hydrolysis? The question is no. So because of that, here it is from a strong base and this is from a strong acid. So the solution becomes neutral. Now let's look at Ba to bracket NO3 subscript 2. So when they dissociate, you are getting Ba2 plus NO3 minus. How do we determine whether the solution will be basic, acidic, or neutral? From the cations that do not undergo hydrolysis, Ba2 plus is part. And we also know that NO3 minus ions do not undergo hydrolysis. So you have this and that combining to give you a neutral solution. Alright, now let's look at some other examples. So we have cation from strong base, then anion from weak acid. What actually happens? These are some examples. So when you have strong base and a weak acid, the solution, pH of the solution is basic. How do we do this? So let's pick one example and see what will happen. Please take note of this. When you take water here dissociates, it will give you H plus and OH minus. So normally I say water attacks. So whatever compound that you are given, you break it down. Then you allow the H plus here and the OH minus to attack. So let's see what will happen. First example. So we have Ca3COO and A. This compound here will dissociate to give us CH3COO minus plus Na plus. So let's pick them one by one. Now the question is, will CH3COOH minus undergo hydrolysis? Will Na plus undergo hydrolysis? We all know that the Na plus here will not undergo hydrolysis. So now the reaction is between this CH3COOH minus and what we have over here, that is the H plus and OH minus. They want to pay this ion here a visit. Now the question is, which one can be combined with what we have here? This is negative and that is positive. So this positive and negative can combine. This negative charge here or negatively charged OH minus here cannot combine with this because they have the same charge. So when H plus combines with this, you'll be getting CH3COOH. What is left behind? We have OH minus, which is a base. So that indicates that the solution is basic. So please take note of that. We are depending on what we have over here. Now let's look at another example. So we have sodium carbonate here. The sodium carbonate will dissociate to give us Na plus, that is 2 moles of Na plus CO3 2 minus. We all know that the Na plus here would not undergo hydrolysis. We are left with CO3 2 minus. So water will attack, and when water attacks, we have H plus and OH minus. H plus here can combine with this HCO3 2 minus here, and that will give us H2CO3. So we'll be left with OH minus, which indicates that the solution is basic. So that is the basic trick. When you split, then you combine them. The one that will be left behind indicates whether it is basic, acidic, or neutral. Alright, so we move. Now let's look at this part. So we have cation is conjugate acid of weak base. Anion is from strong acid. So over here we have NH4Cl, ammonium nitrate, ammonium chloride, CH3, Na3Br. How do we determine whether what we have here is acidic, basic, or neutral? So we will go through the same process, that is the water attack. So we have H2O giving us H plus OH minus, meaning that we are going to work around this. So let us pick one of the molecules here. So we are picking ammonium chloride. Now when ammonium chloride dissociates, you will get NH4 plus Cl minus. And now the question is, which of them will not undergo hydrolysis? NH4 plus is not part of the cations that do not undergo hydrolysis. Cl minus will not undergo hydrolysis, so we'll just throw this away. So we have the reaction between NH4 plus against H plus and OH minus. This is positively charged. This is positively charged, and what we have here is negatively charged. So the positive will go in for the negative. So what will be left behind? That is H plus, and that is an indication that it is acidic. Okay, let's look at a second example. So we have Ca3Na3Br, which dissociates to give Br minus plus Ca3NH3 plus. Take note of this. That is where we position the plus. So we have this Ca3NH3 plus reacting with the H plus and OH minus. So since this part is positive, it will go in for OH minus. So what is left behind? It is H plus, and that is an indication that it is acidic. So take note of that. So whenever you are giving examples, you can just apply this simple trick and you are good to go. Alright, there's a point here. Cation is highly charged metal ion. Anion is from strong acid. So when you have aluminum nitrate, iron 3 chloride, CrBr3 here, that is chromium bromide. How do we go about this? It is the same principle that you are going to apply. If you take this one, aluminum here is not part of the ions that do not undergo hydrolysis. NO3 does not undergo hydrolysis. So automatically the reaction is going to be between Al3 plus and H plus and OH minus. But Al3 plus will go in for OH minus. So automatically you'll be left with H plus, which indicates that it is acidic. Also, cation is conjugate acid of weak base. Anion is conjugate base of weak acid. How do we understand this? So looking at what we have here, if you have, let's say, ammonium compound combining with CH3, Ca2, COO, that is what we have here. We have ammonium combining with Cn. How do we determine whether it is acidic, basic, or neutral? With these examples, what you have to do is you consider if the Ka is greater than Kb, that is the acid dissociation constant is greater than the base dissociation constant. So if you have Ka to be equal to Kb, then we say it is neutral. So take note of that. You can also apply the same principle. Now let's look at a trick here. Pb will undergo hydrolysis. CH3COO will also undergo hydrolysis. So since the two will undergo hydrolysis, we say it is neutral. This zinc here will undergo hydrolysis. HCOO will also undergo hydrolysis. So we can say it is what? Neutral. Now this one here, we can also go through the same process to determine that. So let's pick this example. So as I explained, we have Pb2 plus Ca3COO minus. This one undergo, that one undergo. So automatically it is neutral. Now when you pick the ammonium cyanide here, we have NH4 plus undergoing hydrolysis, Cn minus also undergoing hydrolysis. So that indicates that the solution here is neutral. Please, thanks for watching. Subscribe to this channel and share.